what you've got with LG and this team is just so much knowledge where you got to wonder, like, are they going to really pack it in to this hour? Um, I already started this conversation before we even came on air, saying to them, listen, I want to be super selfish. Here's what I want to get to, just because I know they've got all these answers. So if you're like me and you want to get some interesting stuff out of them, stay for the end. You've got time for questions. You can put stuff in chat if you've got questions. They can get to it. Again, it's a great team. It's a great company. But companies are only as good as their team members, and I'm really excited to introduce to you, if you don't already know, Voya Milashinovic from building from LG, who he is the senior manager, building science and market development person at LG, and you've got Nick Conklin, director, solution planning and strategy. I'm excited to have you guys on.
Thank you, Mike. I appreciate that.
And
Thank you
did I
very
get the
much.
last name right, by the way?
Yes, you did. Yes.
Woohoo!
It is one of those weird ones, and when usually people look at my driver's license, they go, "Wait, it doesn't say Voya." It's like, yeah, no, it's like the whole name's way too long, and it barely fits on a driver's license, so it's just a lot easier to shorten it down to Voya. Milashinovic is hard enough to say already, so plenty enough. But yeah, thank you for having us on. Nick, you wanna jump in and say hi?
Yeah, thank you very much for having us on today. Certainly, this category with hydronic heating and water heating is an area of strategic focus for us at LG, and we've learned a lot entering into the U.S. market with products that were largely designed for the European market. We've done a lot of adaptation to adopt different applications that make more sense for us in the U.S. and Voya is going to get into all that, and happy to help out and add any additional clarity where I can. So thanks for having me.
Absolutely.
Fun.
All right, so everybody should be able to see my screen. Yes? Awesome. Well, let's get right into it. So LG has a ton of stuff out there. As I'm sure many of you are aware, just about every household in America has an LG product. One thing that I did not know is that when we look at globally what LG has as a company, as a product offering, everyone in America has something that is made by LG, whether it be the screen in your car, whether it be the OnStar chip in your GM vehicle, whether it be a vacuum cleaner, an appliance, an air cleaner, HVAC, water heaters, washer, dryer, you name it. What a lot of folks don't really necessarily know is how much of a product offering we have on the water side. So today, that's pretty much what we're going to be focusing on. Is when we talk about the hydronic product offering, we're going to talk about products that not just heat water, but can also cool water. So our goal is to offer a full line of appliances, and I'm going to say appliances not as in kitchen appliances, but electrical using appliances that can handle domestic water, that can handle space conditioning, whether it be heating or cooling, all through water. Helps us lower the carbon footprint, helps us lower the energy footprint, and it just makes more sense, right? Because water is a much better storage medium for energy than gas ever will be. So let's start off with my personal favorite, which is the air-to-water heat pump. Monobloc, just like the name says, and as I'm sure most of you already know, is essentially a system that everything is contained within the outdoor unit. So everything from flow sensors, pressure sensors, the water pump, the expansion tank, which a lot of times is going to be necessary, everything for this system to operate and deliver water at a set temperature is contained in the outdoor unit. This unit currently is an R32 unit in the US market. I saw a question pop up briefly in the chat, and I'm sure we'll get to it and we'll talk about it. is an R290 monobloc product. So we will get to that. We will absolutely talk about it. We'll answer some questions on that. But for today, based on what UL allows us to have, is an R32 product. And I will talk about this product from some lessons learned on my own home. I live in South Texas, not a market that you would typically go to and say, oh, yeah, an air-to-water product, a monobloc product would be great for this market. We felt differently. We figured that, you know what, this product potentially could be great for a market such as hot, humid climate, 2A climate zone in Houston, just from the dehumidification standpoint, that we can play with and utilize some control strategies to make this system really truly shine. So I'll talk about it from this perspective. Nick has been involved in a number of projects in the North and Northeast where it is a heating predominant or solely heating application. So he can talk a little bit about that. Rather than just talking engineering, we'll cover some real world experience and some things that we learned, because believe it or not, this product has been in Europe for about 10 years. It has proven itself extremely efficient over the last 10 years, seeing COPs to the tune of greater than 5, which is incredible. But when we brought it to the US, we build differently, we live differently, we think of comfort differently than Europeans do. So for us at LG as a manufacturer, it has been a pretty steep learning curve of how to take a product that has proven itself so well in a different market and bring it to the States the way we desire systems to operate. So we'll talk about some of those lessons learned as well. So let's talk about some of the applications for the monobloc product. On the hot water side, obviously the biggest that majority of folks on this call are going to be interested in and concerned with is going to be retrofit. How do we get rid of the fossil burning boilers, right? Whether it be a gas boiler, oil, God forbid anybody still has a coal-fired furnace, but I guess if y'all do, how do we get rid of those and still maintain the indoor infrastructure as much as we possibly can? So radiators is obviously going to be, and radiant floor is going to be a huge application up there for retrofits. In a lot of cases, from what I've seen, there is a lot of interest in new construction for the hydronic solutions as well. So this product fits really, really well into that category. Another one is snow melt. Whether it be in garages in multifamily, whether it be just driveways in high-end luxury homes, it works really well. And then I do also have fan coil units and AHU here for a specific reason, and I'll touch on that in a second. The other product use is chilled water, right? This is a mini chiller replacement. Whether it be radiant cooling, in-floor cooling, which the product does have some really cool control strategies built in to allow it to actually operate with radiant loops in cooling demand. Or obviously the easiest and simplest application, which is what I have in my home, is an air handler, fan coil unit, right? Just a standard hydronic air handler that allows me to do some crazy things like drop my CFM to like 100 CFM per ton or even below, without worrying about short cycling the system, without worrying about freezing the coil, without worrying about any of those issues, to where now I can get a 50, 55 degree discharge across that coil, or even lower in some cases, and just wring humidity out of the air. We typically think of Florida and Texas and Louisiana as the humid zone. And while true for the entirety of the year, there are so many coastal and regions like the Ohio River Valley, which during shoulder seasons experience low load conditions with extremely high humidity. So this type of a product really can apply itself very, very well across all climate zones. And then last but not least, domestic hot water. And I'll talk a little bit about my own personal preferences, because, you know, I'm ENFJ, and I'm sorry, I'm an ENFP, and I'm very judgmental, and I have lots and lots of opinions. So I will happily share those with you. You do not have to agree, not obligated to that whatsoever. You are more than welcome to disagree with me and share your opinion with me as well. But nevertheless, I'll share my opinions. So yes, Paul, cooling in the floor. We'll talk about it. So let's move on. This product comes in 3 different sizes: 41,000 BTU, 48,000 BTU, and 55,000 BTU. You can see on the screen what the outdoor and indoor operational ranges are. So I am not going to go too far into that. What I will say that is that the application on the heating side for space conditioning, the first thing that popped into my mind and that a lot of folks have brought up and mentioned has been, oh, well, for the Northeast, for those big old radiators, we need temperatures of like 180 degrees plus. I would love to have a conversation about that at the end, because I have, yet again, like I already warned you, an opinion on that. But we will have a conversation about it. So, talking about these systems in the Northeast, the big question is going to be is how much capacity do you lose in extremely cold situations? You do lose some capacity, yes, which is why these systems have been designed to allow use of a backup heating element in multiple different scenarios. So if we are using a buffer tank, whether it be a direct buffer tank or an indirect buffer tank, the easiest thing is to use a tank with an electric heating element built in that can be used as makeup. So in addition to the input from the monobloc, we're just simply adding that required capacity that's needed for those ultra low temperature times. Or we can use something that is a secondary heating source, whether it be a furnace, whether it be all electric gas, whatever may be the situation. So the system is really designed to just be flexible and allow for use of any type of a fuel source in addition to its own heating capacity. Can we add an external pump? Yes. Like I said earlier, there is a variable speed Grundfos pump built into the system. It is a pump that is capable of speeding up to 12.5 gallons per minute and as low as 1.25 gallons per minute, I believe, is its lowest capacity, which is 10%. But in cases of larger systems, multiple zones, indirect buffer tanks, where we know based on our design that it is going to require more lift than what the pump can provide against that head pressure, we can add multiple pumps depending on what we need through just a simple addition of a switchboard, like a zone control board, right? One of the things that LG did in designing this system was made it very, very brand agnostic and product agnostic on anything past the pump built into the monobloc. So in other words, if you have a preference for control boards, for thermostats, for buffer tanks, heating elements, pumps, you name it, as long as it matches the spec that our product can deliver from a capacity standpoint, you're welcome to use any of those products. Our team is here to help design it so that it makes sense. Most of the times that we have seen issues, failures, and low COPs with this product, both in the States and especially in Europe, is when it has been over-engineered and over-designed. So that is kind of one of the big purposes of our team and Nick and his folks that he works with, is to just make sure that we are designing this product to deliver exactly what we need it to deliver without any added on bells and whistles that can compromise operation. So we can do heating and cooling using two-way valves. that's something that I've considered doing in my own project, my own home. I don't see a need for it quite, but I do want to play with it just to see what I can do, what I can make it do, right? Because I want to force this thing kind of like, and we've already done it. Nick will attest to this. I think, what did it take me, Nick? It took me less than a month to make my controller crap out.
Yeah, about that. It's about
Yeah,
right.
yeah, because like I'm a firm believer, and Nick won't share this with our corporate folks because then they would just basically slap me down. But the Elon Musk method of we're gonna test this crap until it fails because we're gonna learn far more from failure than we do from success. And what I did learn is I learned that I cannot do exactly what I wanted to do and put the controls exactly where I wanted to put it, where I want to put them, and try to use tricks to fool the system. So the engineers that designed it were way smarter than I thought I was. But nevertheless, I want to play with it. So the ability to do both heating and cooling simultaneously with this system through using valves and tanks is absolutely something that can be done. Okay,
And
so
boy, just to add to that, I think that is one of the beauty parts of this system is it is so scalable and configurable. All of that comes with cost trade-offs and things that need to be looked at as we're designing applications. So it's been a benefit and a challenge, I think, for the industry in many ways to adopt some of these things because they're so used to cookie cutter DX systems where it goes in exactly the same way, it looks exactly the same way, and this one is so customizable and configurable that people oftentimes have trouble dialing into specific applications and what they need. So always good to consider what somebody's trying to do, the cost impacts of design decisions, and how we can make sure that we fit the comfort needs of the occupant as well as the cost needs.
yeah, absolutely. And I will say it has been my experience that the moment someone tells me, whether it's a contractor, engineer, designer, that says, I've been doing these things for 25 plus years, so I don't need your team's help in how to lay this out because I know what I'm doing, I run scared because they are new. This technology has changed just in the last year and a half too, so much that most of the times it's when we know what we're doing that we kind of tend to screw ourselves. So I'm not going to go through a whole lot on this screen because you guys see, 4 different ways of doing it with a whole bunch of different valves. If you want to take a screenshot of this, please by all means do so. This is just simply here to say, like, you can do all kinds of crazy crap. Just combination of tanks and valves. Can we do multi-zone control? Yes, we absolutely can. There are some native multi-zone controls built into the board on the monobloc itself. I'm not going to go through that because it gets really crazy, kooky, and complicated for the time that we have today. But suffice to say, you can do multi-zone control with our system built in using some of those features, or just completely allow the system to do what it's designed to do, which is provide you with either hot or cold water, and then zone the crap out of what you want to zone out using accessories that are available to you at your local supply store, right?
And just to add some color to that, most of the time people are using the Taco zone control valves along with a variable speed pump after the buffer tank, and then that goes to a Taco zone control panel to feed back in the contacts to our system to tell it when to run into heat and when run into cool. That's the most common application that I've seen so far. So most people tend to steer towards that because then you can use common US controllers and it's just more US centric in terms of what people are used to using inside their homes.
So just another screen that just shows different capabilities of multi-zone control through various different valves and different controllers. Speaking of fan coil units, I'm going to go ahead and back up a slide here. So we have this unit kind of laid out in a picture as a fan coil unit just because it was easy, and that's what our Asian and European counterparts sent, and we were just too lazy to go and kind of draw up something of our own. We do have, and I'm going to ask Nick to touch just a little bit on what's coming. We do have fan coils, LG native fan coils coming to the market shortly. Believe the two first units coming in are going to be the pancake style, so the ceiling fur down style ducted air handlers, slow static and medium static, and then the four-way ceiling cassette that are coming, capable of functioning in a fan coil unit application using LG controls native to the monobloc system. There are plans for expanding that product line, but I'm not high enough in the HQ yet to know what those look like. I don't know that Nick is either, but you know what? Nick does know some stuff that is maybe a little bit more detailed than I do. So Nick, you want to just kind of jump in and just briefly touch on
to give just kind of a high level roadmap for us, we recognize the benefit of having more ductless style fan coil units like high walls that can attach to this monobloc system. And so Voya is right about the medium static ducted and the four-way cassette being the first to come. And then after that, we're working on a high wall development. So more of what you would traditionally get from a ductless mini split. And then we're going to be looking at our US style air handler over time as well to bring that in so that we have that as an option. The big benefit we do get with hydronic systems today is, as Voya mentioned earlier, we can really be manufacturer agnostic. The water does not care what fan coil unit it's going to. It does not need to communicate directly, unlike what we get with the mini split systems that do require communicating controls most often. So we can go out and source third-party fan coil units, get them selected. And in fact, that's what we did for Voya's house to get him more of a residential style air handler in his home. So look for more to come for that. Certainly as this market continues to expand, we'll add more to our portfolio to have a more holistic offering. But we are leveraging a lot of third-party products today in the marketplace to make sure that we have a complete offering regardless of what application we're looking at.
And then, Voya, I'm not going to interrupt too much, but there are so many good questions. And by the way, this is an incredible presentation so far. But one of them I think is an interesting one from Jordan, which is, can you talk a little bit more about how it actually works to do both heating and cooling without switching modes?
So Voya, do you want to cover it or do you want me to cover it?
No, go ahead. Because I mean, you and I have spent like enough time talking about
it. Yeah, so
it's a big deal. It's important.
So there's some different ways to do it. And as I said, everything goes back to some cost trade-offs when you're looking at this. So the ways that I've done, we did a project in California in the Bay Area where they actually did heating and cooling this way. And they had the space and capability of doing two separate buffer tanks. So they actually had a hot water buffer tank and a chilled water buffer tank. So they would charge both of those up as needed so that they had both hot water and chilled water available at any given time, and then also helped to allow the system to carry it through its defrost periods and things like that so that we were able to do that. It also is helpful to have that sort of arrangement when you're trying to add in domestic hot water, which adds additional complexity into the design. But they wanted domestic hot water in this application, so that allowed them to run the domestic hot water system while they could still provide cooling to the fan coil units as if they were calling for cooling at the same time. So that's one method of doing it. The other method is to utilize our changeover function that we have built into the system, which will change over the heat cool based on outdoor ambient temperature. And it also allows us to do hot water temperature to reset on the system, chill water temperature reset on the system. So it would simply change over the buffer tank depending on outdoor ambient temperature, allowing you to do heating and cooling out of that system. That doesn't get you the simultaneous effect, but it does allow you both of those to both heat and cool with the system effectively. It just, again, we can do it all. It depends on what the budget looks like and how much space do you have to manage buffer tanks.
That's a pretty wild setup. So that's like almost a set it and forget it setup for real.
Yeah, yeah.
I mean, because we all say it, but you know, it's not really set and forget it, but that really could be.
To a degree, yes.
Yeah, of
So,
course.
you know, the only thing that I'll add to what Nick just said, because I think he covered it extremely. Wait, let's put it this way: he covered it better than I would have. I would have taken another 5 minutes to talk about it. It can be done through the use of 2 buffer tanks. It can be done with 1 buffer tank and a bypass valve. So there are ways to do it. What we would recommend is, if you have an application where you desire and you think that simultaneous heating and cooling would be useful with a monobloc, please reach out to us, get together with our team, and we will work with you to help design it so that it makes sense for your application. Okay. Another thing that the system is capable of doing natively is 2-circuit temperature control. So the unit is capable of, through utilization of mixing valves that are controlled by the logic on the board and our controller, is to essentially provide 2 different set points or 2 different temperatures for 2 different circuits. Not sure. I guess some situations where that could be really helpful would be that hot water for domestic versus hot water for your space conditioning, especially if you're utilizing things like fan coil units in one area and in-floor in another. Like my best friend has a true split level 50s in his home where the lower floor has in concrete radiant, where he wants a low hot water temperature. His mid-level has radiators, and his upper level, which is where the bedrooms are, has fan coil units, because that's the only place where he wants a little bit of air conditioning, you know, during the summer. So he literally has a home that's designed where he wants, for his space conditioning, he wants both a low temperature for the in-floor and a higher temperature for the radiant and fan coil. So just, you know, one application that comes to mind.
Now, and boy, I've actually done exactly that application in the Northeast. We did a job where we did this. Now we didn't use our system to control the different temperature zones or circuits that they had in the system. We simply ran the monobloc to the buffer tank, and we maintained the buffer tank at a slightly higher temperature. We had some medium temperature fin tube radiant, which was operating at 120, and then they wanted a radiant floor system that they had operating at 95 to 100, depending on time of year and what they were trying to do with it. We would just simply mix down that 120 degree water to 95, and that was controlled again by a separate panel and an aquastat that just strapped on and then fed back to the control for that mixing valve. So we did it that way versus tying it all back into the system, and that tends to be the way that I have recommended most of the control go with this system, is that we sort of draw a line at the buffer tank, and everything from the buffer tank going inside of the home tends to be third-party control, and everything from the buffer tank back to the monobloc is controlled by the monobloc system. And that, again, tends to be the way we do most of our applications here.
Yep. Thank you for that. All right, so let's talk about the domestic hot water tank. We're not going to talk a whole lot about it, but we are just going to touch upon that, yes, it is doable. Yes, it can be done. We kind of mentioned earlier already that we can do simultaneous domestic hot water as well as space conditioning through use of various tanks and valves. Do I like this option? No, I do not. I am not a fan in a single family residence. I am not a fan of utilizing the monobloc for both domestic and space conditioning, just from the perspective that it's a single system rather than 2. And the cost of it becomes much, much greater versus doing something like this, where I'm utilizing my monobloc to handle space conditioning, which is exactly what it needs to do. I'm utilizing a heat pump water heater to take care of my domestic hot water, which is a lot lower upfront cost. It is also a lower operational cost. And it also gives me if I want to really, really go crazy, which occasionally I do, it gives me the ability to now have the domestic hot water, the heat pump water heater, as a backup in case of a failure on my space conditioning system in the winter. So it simply just allows for backup. And for anyone who, like myself, went to school for computers, programming, network technology, doesn't matter what computer science you went to, one thing that was drilled into you is backup to a backup to a backup. Like secondary and tertiary redundancy is God. And I just like having redundancy.
Yeah,
So,
question.
yes.
Yeah, the just in a standard HVAC, space conditioning configuration, roughly what the COP for heating and the EER for cooling.
Nick, do you
Sure,
have
I can cover that one for you. So it's going to depend. The COP will change both for heating and cooling depending on what your GPM is, what your outdoor temperature is, and what your desired water temp is. Now, when just to kind of give you the range of where it's going to fall, when we are at somewhere around -5 outside, if we're trying to produce 120-degree water, our COP at that point is going to be floating right around 2, somewhere in that range, 2 to maybe a little under 2. If we are trying to produce that same 105-degree water at 40 degrees outside, our COP is going to be in the 4.5 range, somewhere like that is what we've seen on our side. And then it depends on the electrical consumption of all the other components in the system. So it does vary. We have charts in our engineering manual that you'll be able to take a look at that will give you an idea of what the system, the monobloc unit COP would be on its own. And
Yeah,
that can give you some indication, but that's the general range that it floats in, but it does depend on how you've designed the system.
yeah, I'm in te Houston, Texas, so it would
Yeah.
be the cooling side of it. So I'm real interested
So
in
the
an
cooling side,
EER.
it does depend on what you're getting, and we're going to run EERs in the range of, I would say, 12 up to about 17 to 18, or what we see on the system. Again, depends on how cold you're running your water. The colder you run your water, the lower your COP goes, and the more mild it is outside, the better you are. So generally speaking, we're running about the 12 EER range on our design temp days, somewhere in that range, and then we get much higher as it gets more mild out.
Yeah, I'm debating two systems here, and one's the Series 7 water furnace, and they're looking like 24 to 30 EER on those. So that may, but that's for the cooling thing.
Right.
Yeah,
And
so
that's for a geo system, right?
correct.
Yeah. Yeah.
Yeah, in fact, on their 7 is like 42 to 47 EER. So I think that's probably answers my question there.
Cool.
Yeah, I'm not going to claim we're achieving ERs that are in the 42 range. That seems quite high to me.
Yeah, for air to water, is it possible? Maybe, but it's still far off. All right, let's move on and jump into the Hydrokit real quick. I'm not going to go too much through the Hydrokit because, again, think of the Hydrokit as essentially a monobloc that's just been split in two. But what it does give us is the ability to utilize indoor DX units. So for spots where I want DX for the cooling application, I can utilize DX in combination with hydronics at the same time. And it just does so with less of a space requirement. Slightly, well, not slightly, more expensive for sure, bigger investment, but it opens up quite a few possibilities as far as the flexibility of the system. We have two different Hydrokit chassis. One chassis that provides hot water up to 122 degrees when you say HR on the previous slide,
That stands for the heat recovery box, or HRU, heat recovery
oh, yeah,
unit, we
right
usually
there,
call it.
HR, heat recovery unit. So it's for the units, the DX units that allow us to do simultaneous heating and cooling. So thank you for that question. So like I said, the smaller chassis, which is our medium temp, is up to 122 degree water. And then we have a high temp chassis, which provides water up to 176 degrees. We are working on some new stuff that is larger than this for the larger multifamily or commercial applications. But that is something that if we have some time, Nick might jump into, or we can really talk about in more detail next time we all get together, because I am going to leave you with a little bit of a teaser for next time. So again, the medium heat kit also has the capability to chill water. So that's part of that teaser that I'm going to leave you all with, and I'm not going to talk about it too much here. I just simply want everybody to kind of know there are two different heat kits. One is a high temp, hot water only. One is a medium temp, ideal for space conditioning, low temp to mid temp, as well as cooling application. Do we need to go over this? I mean, essentially, it's just a heat exchanger inside a box.
Yeah, I think we can move through this pretty quickly for you.
And then same thing with the second heat kit, the high temp Hydrokit. Again, it's a heat exchanger in a box with an added small compressor in there to give it a boost.
And just so everyone knows, we'll be shifting to 513 once we shift the entire system to 32. So that's what's in the process of redesign right now.
So again, applications, combination of domestic hot water with space conditioning through the hydronic components, with the ability to add the DX indoor units in certain spots where we need some spot heating, cooling, especially in the shoulder seasons. All right, I'm going to jump through most of this because we've kind of talked about it already. And I'm going to jump to the inverter heat pump water heater. Okay, so I'm going to tell y'all we have a heat pump water heater. You see the picture of it, it looks sexy. I'll tell you some of the big things about it. What I will also tell you that if you really want to know more about the heat pump water heater, I'm going to do a shameless plug. Please, please, please come join us at the Heat Pump Summit in Worcester, Massachusetts in November. We're going to have, I want to say, 3 or 4 sessions on heat pump water heater. Everything from history of heat pump water heaters to where we are today, to how to really truly design our homes around a heat pump water heater so we don't cause issues and we don't cause unhealthy air. And then we'll have, I want to say, 4 or 5 air to water heat pump presentations from various different folks like Nick and Ross Tertui and a few others that'll be on there talking about these products in a greater detail. But for the purposes of this presentation today, we have a 50-gallon and a 80-gallon heat pump water heater. The 50-gallon is nominal at 58 gallons, and it is a 76 gallons first hour rating. The 80-gallon is nominal 80 gallons, and first hour rating is 94 gallons. This first one right here, the 76 gallon first hour rating, is the reason we do not have that mid-size of a 60-65 gallon tank, because we don't have a use for it. We are able to achieve in a 50-gallon tank what the competition does in a 65. The big things that I would like you to take away from this is, besides obviously that first hour pass through, is the decibels. This unit runs to a 42 decibel sound level, and when it runs in turbo mode, that's to the walls, 45 decibels. That is extremely quiet compared to what we have seen and what we have been exposed to in the past with heat pump water heaters. This is ridiculously low noise levels. The unit is tall. Okay, there's a big tank in there and a nice size compartment for the compressor, so we get the efficiency and the heat transfer we need. So it is a tall unit. If you look at it right here, the height on the small one is 63 and change, and on the 80-gallon, it's 79 and change inches. So be cognizant when planning a space for these. We already kind of covered this. We do have 3 different styles of unit available. Standard model, we have a model with built-in leak detection, and we have a model with built-in leak detection and demand response. I'm sorry, model with demand response built in, and then a model with demand response and leak detection built in. So quick little brief video of what the components are. The heating elements are standard heating elements. The anode rod is a standard anode rod. So if you need to service the heating element, if you need to service the anode rod and replace it, it's just a trip to a hardware store, pick up the size that you need, and plug it in. The panel on the front pops over or pops open, and everything is serviced through that panel. The advantage of the dual inverter compressor is just simply going to be, again, that noise level and the efficiency. When we say efficiency, we're not talking efficiency just based on COP or UEF, which is, I'm not going to talk ill about the government because they're probably listening to me right now. But I will say they're not very fair to all technologies when it comes to their testing standards. Where you will see a huge increase in efficiency with a dual inverter versus just even standard inverters that we're used to that have been around for 10, 15 years is going to be the amount of heat that you actually get to put in that water versus the competition. And again, this just simply tells you why the heck we get so much more hot water. Because the dual inverter technology just allows us to ramp up the compressor much, much higher, and we're there.
And Voya, just to touch a little bit on the inverter and its benefit, outside of just efficiency, what it does more than anything is protects the compressor from failure. Unlike cycled systems, which have inrush power and hard starts and tend to be plagued with higher compressor failure rates, we found that our compressor failure rates in the US are very, very, very low, and we've seen the same data from the European markets as well. We have yet to replace a unit in the US due to compressor failure out of the multiple thousands that we have sold. So the capability of the compressor to run for its lifespan is much better because it is better protected with that inverter operation.
Yeah, and I should have clarified that. So thank you, Nick, for clarifying that. I appreciate it. I just thinking of my previous component spotlights in my previous life with PHA, I just figured hey, everybody's familiar with inverter. We already know there's no use of talking about any of the ancient technology. We're not riding on horse-drawn buggies anymore. So why even talk about single-speed compressors? But it is important, yes. So thank you for clarifying that. The vast majority of heat pump water heaters installed even today in the U.S. market are single-speed compressor heaters, water heaters. Which is the reason why we are seeing failure rates greater than 40-45%, and seeing the noise complaints. That is a massive difference between an inverter compressor and a fixed speed compressor, whereas a dual inverter compressor, just simply takes that benefit of an inverter compressor a step further. So it's essentially the next generation. All right, let's jump through this because I know we don't have a whole lot of time left. So like Nick mentioned, no inrush current. It does give you the optimal operation for a backup generator or a battery backup source. So if we are building all electric with either a electric car built in or a plugged in that is being used as an energy source in case of a power outage, a generator, or just simply batteries, the inverter compressor is really the best way to provide longevity for not just the compressor itself, but for the generator or the battery that we're using as backup source. These are heat pumps, right? So they are going to pull heat from the air, meaning we got to think about where we place them, and we got to think about what we are going to do with that cold air coming out. With the LG heat pump water heater, you are going to get upwards of 200 CFM of air when that thing is running full tilt. That 200 CFM of air can have a degree difference between incoming air and outgoing air of up to 15 or 18 degrees in certain situations, right? So we gotta be cognizant. If we put this thing into a small closet and we think that just a slatted door is going to provide enough airflow for the temperature to never reach dew point, we are mistaken. There is a darn good chance that that space, especially the space inside the cavity, the interstitial space in the wall, reaches dew point, and we start causing problems. So we gotta make sure not only that we are feeding the water heater that comfortable conditioned space in that 60 to 70 plus degree range, whether it's in a basement or in a closet, but that we're also managing the outgoing air efficiently, whether that means we're ducting it and ducting it into the space where it can be mixed with the rest of the volume of air inside the conditioned space. What I don't want to see us doing is exhausting the air outside. I've seen this in multiple case scenarios. What you have done now is you've basically activated a 200 CFM exhaust fan that is now going to have to bring in air from outside anyway. So not only are you adding more money to the conditioning of your space equation, but if you're just feeding the unit cold air in and cold air out, you run a chance in those low temperature conditions of turning your heat pump water heater that you spend good money on into just a cheap electric water heater. Why? Right? So yes, this unit is capable of going down far, far lower than standard heat pump water heaters that you've been used to. A typical standard water heater you're used to right now in the market will cut out the heat pump and switch to electric only at around 40-ish degrees. Some may go into the mid to high 30s, but that's about as low as they'll go. And then they switch. This unit will go down to 21 degrees ambient before it shuts off the heat pump and switches to electric only. So far, far better operation from a heat pump, but why? When we know that the lower the temperature, the lower the COP, or UEF in this case, let's think about where we install them so that we are giving this unit its best chance at success. Smart control simply means that this unit comes with ThinQ module built in. We can hook it up to Wi-Fi, and we can control every aspect of this unit through the app. The unit has 4 different modes that it operates on. It's going to operate in auto mode, which simply means that it is going to look for a 22, I want to say, Nick, correct me if I'm wrong, but I believe it's a 22 degree delta between set point and water temperature in the tank before it activates heating elements in addition to the compressor. So it's going to run both the compressor and heating element at the same time.
In the auto mode, that's correct. In turbo mode, it's a little bit lower. It's
in turbo mode is going to look for a 12 degree delta.
Yep.
Before it activates the heating element. And then we have the heat pump only mode, which will simply lock out the heating elements, and it'll only operate in heat pump mode unless there is a failure of the heat pump and it needs to switch over to the emergency. And then it is going to have also vacation mode, which simply means that it's going to reset the set point of the water heater to conserve energy if we know we're going to be out of the house for a number of days. And we actually can schedule that and essentially tell it like, hey, vacation period is from such day to such day. This unit is smart enough then to know, just turn the unit back on and have the water ready to the temperature I need it when we come back home. I saw a question come across, and I think it's going to touch upon it here in just a second. I'm not going to cover the differences in installation between electric versus heat pump, other than you need to have a condensate line, which you don't with an electric. And typical electric water heaters are going to have all your pipes at the top. LG's water heater pipes are on the side.
Boy, the only thing I'll touch on with this really briefly is that one of the challenges we face as an industry, specifically with the installation, is the resistance to change that we get from specifically the plumbing community when it comes switching from electric to heat pumps. So we do a lot of training. We have online available training courses for installation for this product, but getting people more comfortable with these technologies, understanding that they won't have to touch or interact with the refrigerant circuit inside the system. In fact, we fully replace the product if there is any issue with the refrigerant circuit inside the system. We offer a 10-year warranty on this product line, so it has all that integrated into it. Whereas I said we will do a full unit replacement. It's really just educating the contracting community to be more comfortable with this technology and not be so gun shy about offering something different.
Yeah. And I saw a question that popped up that said, can we duct this unit? Yes. Both intake air and exhaust air can be ducted, various different configurations, as you can kind of see in the pictures here. Again, please come and see my heat pump water heaters level 2 presentation at the Heat Pump Summit, or join us virtually if we do end up offering that, which I think we will. I'm going to talk primarily about ducting, when to, how to, the heat pump water heaters, to make sure that we do not run into issues with condensation inside the walls or surfaces, mold and mildew. And this is all directly in response to and in conjunction with lots and lots and lots of wine and other alcohol shared amongst conversation with Dr. Joe Stieberich and Gary Klein, to really kind of dive deep into, oh crap, what can we get ourselves into? So how do we tell people to think about preventing it? So please, please, please come out, because we don't have enough time to cover that today. But yes, you can duct it. This 700 cubic foot mech room size, we're still unable to convince our engineers and lawyers to take this out, as any other manufacturer will attest to. I don't like this number because it is never going to be a hard and fast number. Let's have a conversation about your application, and then let's talk about, is there a potential for issues or not? I don't want anyone to come in and say, oh, well, I did it exactly 700 cubic feet, and we still have a problem. Yeah, in certain applications, you're still going to have a problem, right? So this is not a hard and fast rule. And
Yeah,
the only thing I'm asking you all to do is scan this QR code. Then, scan that QR code. And when it takes you to the website for all of our hot water solutions, please save it and then reach out to us with questions. And I'm going to keep popping it back over because, I should have turned off the little time thing. So what I'm going to do next here is, because we are right at 12 o'clock, so I know some folks may have to go, but if you want to have questions, I am here. I don't have to run anywhere. Mike can kick me out when he thinks is fit. I will say this because I promised you all a teaser. I would love to do another chat, not a presentation. Let's call it a fireside chat without the fire. Imagine if we were able to do and work together with the industry to do a feasibility study. Imagine if we could take passive or close to passive high rise. So good high density, right? The kind of projects we all love because they make passive make sense way, way more. And if we were to able to utilize the technology LG has to provide domestic hot water, space conditioning for both heating and cooling simultaneously through the use of a single product offering that reduces the amount of electrical panel space needed, electrical runs needed, that reduces the amount of outdoor units with refrigerant bearing units, right? And it helps us reduce the amount of refrigerant required on the job site, but has the ability to provide, like I said, both domestic and space conditioning, cooling and heating, all through the use of hydronics. So no DX systems inside the space. Through shared, what's the word I'm looking for? Shared volume, I guess, would be the word. So just imagine in my mind what I'm imagining. I'm imagining 3 tanks. 1 tank dedicated to hot water for domestic use. 1 tank dedicated to cold water. 1 tank dedicated to hot water during those times when we have a need for both cooling and heating in the same space. But at the same time, we have the ability in the deep of winter to increase capacity by making both of those domestic tanks hot, and the capacity to make both of the tanks cold in summertime when we don't need space heating, but we need capacity of space cooling. So I'd love for y'all to just kind of think about some craziness that could be done if we could do this. Because just like the $1 Million Man, we have the technology. We just need to build it. And I'd love to talk to y'all about partnering up and saying, hey, let's feasibility case study the crap out of this and see. Does it make sense operationally? Does it make sense financially? And if it does, we have the partners and the product to actually put this together and make it a reality. So with my soapbox done and pulled out from underneath me, any questions y'all have, please.
I'm in. I feel like the accelerator's in. Reimagine building communities totally in. Let's have that second session. I think that's cool, and I do agree. I feel like that would be wonderful. In terms of questions, this has been super popular. If everybody know, you should already know this, but if you don't, all these things go on YouTube. So in the next couple of days, it'll be on YouTube. You'll be able to see it. Very cool. We have like 1 billion questions, plus or minus.
Look,
So,
last component spotlight I did, we had what, 250 some attendees?
yeah,
And 100 plus of them stayed for 45 minutes after we were done.
Yeah, you got
So
a lot of questions. Let's I like that. So, if you're able to come on screen, Kim, if she hasn't done it already, we'll throw on who's first, second, third. If you're able to come on screen, ask the question quick, and if we can keep it going, let's have some fun. I'm available if you are.
Yeah,
So,
quick.
Gene, you're first. I'll call on the people if you guys don't mind. So, Gene, you're first.
I'm wondering when you think propane will be available in the U.S. For these air-to-water heat pumps to deliver high temperature water for existing hydronic systems.
Write your congressman and your government official, because we have them. We are ready with them. We want to bring them in. We have to get that stupid UL listing to change. Nick, go ahead and
yeah, I'll add to this. Preliminarily, we've been told by UL that they don't think they'll see an update until 2030. Again, I think with additional push, we could see something sooner. We are doing some studies here with some different utility groups and some groups in California to help to get some additional data and help to move it forward. Anything we can do, I think it's a priority for us. We see that's where the technology should be going to. It's been utilized widely in Europe for a long time, so definitely a route we want to push, and any help we can have in pushing to help move the whole thing forward, we welcome it.
Is my understanding that ASHRAE is the obstacle right now until they approve it? UL won't touch it.
It is a blend of both of that, yes. Until the ASHRAE 1534 committees pick it up and develop the safety standard around A3s, yes, that's an issue. It also is an issue, and we're trying to get them to look at this as just doing something that would provide allowance for a monobloc style system or an HVAC system where the refrigerant does not actually enter an occupied space, where it is all contained outside of the building. And so we are trying to get them to look at it that way versus trying to boil the ocean, so to speak, and try to manage everything all at the same time. So it takes time to course correct these large ships, and the more push we get to move it forward from the industry, and the more push we get from consumers requesting this, will only help to accelerate that.
All right, next question is Erdem.
Yeah, thank you, Michael. Does LG offer antifreeze valve to avoid glycol in the system, since this is a monobloc application?
In terms of glycol in the system, I'll speak to that. We generally utilize glycol in the system. I don't think there are many systems out there that we haven't added glycol to, and just depending on the outdoor temperature that we're dealing with, we have a variety of percentages. Whether you want methanol or propylene, we can do either one of those. I do recommend that you don't try to isolate the glycol in the system using an indirect buffer tank or an indirect heat exchanger to separate out the system, only because you do lose efficiency in that. And I found that the efficiency penalties that you pay by not just leveraging glycol throughout the entire system are much higher than they would be if you just allowed glycol to flow throughout the whole system. So my recommendation is direct buffer tanks and allow glycol to be utilized throughout the entirety of the hydronic system.
But there is no antifreeze valve to...
There's no antifreeze valve built into the unit. We do allow you to add in a freeze protection drip valve. So if you wanted to add that in as an accessory, you can certainly do that also. We do have pump controls built into our system that will automatically cycle the pump based on the outdoor ambient temperature, and that is adjustable in our controller. So there's a lot of things we have built in there, but obviously if we lose power to the system, then we're not going to be able to do pump cycling and things like that.
All right, next question up is, and great answers, by the way. These are the good start off to our question and answers. Chris, you're up next.
Hello. Can you talk a little more about the hydronic cooling you mentioned briefly? I think you said it was done through the floor and not through the ceiling. How are you controlling dew point and condensation?
Yeah, so that was specifically in the Southwest. We did an application where we did in-floor radiant, and then they also did in-floor cooling. They use the same loops to do in-floor cooling, and that's something we can probably only do in the Southwest part of the country because of the dry climates that we see there. But what we're doing on the design side is we're evaluating what dew point we think we're going to see inside of that space, and then we will design the water temp such that it's never going to hit that dew point condition. Typically, we're operating in the 60-degree ranges where we found works best.
So you're just monitoring for dew point and not trying to control it?
We're not trying to control it. No, it's simply just setting up the water temp to avoid getting to the point where we're close enough to see dew point.
Gotcha. Yeah, I mean, if you're able to control it, then you can go into other even New England or other areas. So
Yeah, now through more advanced control strategies, we do have the capability of doing that. So we have a Modbus controller that we can design custom programs in to get into that and do some of either passive or active radiant cooling with the system. So as I said, anything can be done. We have so many controls capabilities with this system. It just depends on the cost.
gotcha. And I'm on the list later, so I might as well ask now. The installers required, is that plumber and electrician, or do you also need an HVAC person on site?
I mean, technically, we're not working with any refrigerant, so we've had plumbers just do these, but these are fairly complex designs. So finding plumbers that have expertise in hydronic radiant systems tend to be the best in terms of putting these things in and having them go correctly. But we're open to training people, and this is again something I think that we're going to need to get the industry more comfortable with to reach some level of scale with this product line, is to get the guys that are much more comfortable with DX, more comfortable with simplified hydronic systems, so that they're good to work on those too.
Yeah, amen. All right, thank you.
All right.
Yeah,
Yeah.
I'm gonna add to that just really quick. We want this product to be successful, and I know that this community wants this product to be successful. And I'm not talking about just the LG Monobloc. I'm talking about the air to water product all together. The key to that is going to be demand. I've spent years as a contractor, and I spent years now in the manufacturer field on the DX side and water side, specifically working with contractors distribution on the training aspect. Until they have a project, they don't want to come in and train, because their whole idea is, well, why should I? I already know what I'm doing already. So what we are going to need help from the community here is, let's get some of these products specified, and then let's work together with the manufacturers, with the contractors in question. Let's get them trained up before they go in and screw it up 4 or 5 times, before we go in and say, well, you should have trained. You should have gone to the manufacturer's training to learn how to do this. No, let's get them to the training first. And I will tell you that for one LG, because that's the only company I can speak for, is we will invest the time and the energy and the effort needed to bring that training to the contractor and to actually even go to the job sites to make sure that it is being designed and installed correctly, until that contractor gets comfortable, and then we can just kind of grow from there. So let's be the mustard seed.
Great, thank you, Voya. I'm going to step in for Michael for just a second. Next, we have John Foster. It looks like you are here. Would you like to come on and ask your question?
Yeah, thanks. Yeah, maybe I want to reframe my question a little bit. It was really looking at MERB retrofits in general, apartment building retrofits, and what you see for your current lineup, and maybe directed back to your design challenge at the end there. In your current lineup, what applicability for retrofitting MERBs to hydronic lower temperature? Kind of for future compatibility with potentially district energy and TENS. We're having a lot of conversations about that. So to make it not a stranded asset, if it was compatible for future and has some of your existing monoblocks supplying it, so small fan coils, I imagine, in individual spaces and domestic hot water, and having energy meters per apartment, hydronic energy meter.
Nick, you want to touch on most of that, or you want me to talk about the monitoring side and the energy measuring side that I've seen applied?
Yeah, I mean, certainly we've done and can work with flow meter type applications for that. Now, depending on the size of the facility that we are trying to look at, I know we didn't get into our heat pump chiller products that LG offers, but we do offer some larger 3-phase inverter scroll chiller products that have the capability of both heating and chilling water as well. And so depending on the scale that we're looking at, the complexity that we're looking at, it may make more sense to go that route. It just depends on what we're looking at. But I've had people break that up by installing flow meters at the individual tenant spaces for the fan cool units, and then they monitor flow and appropriate the energy consumption that way. But Voya, feel free to add in.
Yeah, that was really the only thing I was going to add is that those types of applications, when it comes to tenant energy charging, right? I've seen two ways done. One has been through the utilization of controls and algorithm, and then the other has been through the flow valves or through the flow meters. I believe flow meters have a much more promising option, because the other option that I have seen utilized, I've also seen that very same option have like crazy massive lawsuits against it because it just didn't work very well. So I do love the water approach versus the central plant DX approach much more, because it does allow us to simply say, hey, we used X amount of energy or X amount of electricity to maintain this level of energy for heating, cooling, domestic in the space, and each space used X amount of gallons of water for domestic conditioning and X amount for domestic water, right? So it now becomes much easier to tell where did the energy go specifically, rather than trying to use algorithms to just guess based on square footage, right?
Hey Voya, I apologize. I gotta hop off. I'm at time on my side, but I want to thank everyone for the time and any additional questions on my end. Certainly willing to answer those via LinkedIn or email. And Voya, you can stay on and answer questions. Feel free to keep going. Just thank you for having me and appreciate the conversations.
Nick, this
and
was great.
any questions that are Nick specific questions, I will make sure to give everyone Nick's personal cell phone number, and they can reach out to him and ask directly. Yeah, tonight.
Love that.
Yeah. All right, thanks, Nick.
Thanks, everybody.
Thanks, Nick. So the next question is from Anna.
Hi, great presentation, by the way. I have a question for the hot water heater, the heat pump hot water heater, specifically for cold climates, only because it's drawing the conditioned air, which as it gets colder outside is more expensive to provide. And so I think someone else had asked it as well. Is there a way to mitigate that cold air that's getting dumped into the space through an ERV?
Okay, when you say the cold air that's getting dumped into the space, are you talking about the air required coming in from outside to operate the heat pump water heater efficiently, or you talk about the cold air that is being discharged from the water heater and being dumped into the space?
The discharge air, because the discharge air can be as cold as like 13, 14 degrees Celsius. I'm not sure what that is in Fahrenheit. I'm from Canada.
And I have not thought in Celsius for a very long time, but I have a friend named Google. That's about 55 or so degrees. So here is what I will say. It can get that cold, yes. What I would say is this. If your indoor air is 70 degrees, then yes, seeing that 55, 54 degree Fahrenheit or 13 Celsius or thereabouts is absolutely what we will see. What I will say is this, and this is simply based on some CFD calculations done. We are talking about an intermittent 200 CFM, so it's not constant. It is only when the unit is running at full blast. We do see closer to 100 CFM when the unit is just catching up and maintaining, and it's not having to raise the water temperature by a huge delta. And I say that for this. 100 CFM of air at 55 degrees being put into a 70-degree space, and let's say we're talking about a 1,500 square foot dwelling. If we are placing that in areas that are not areas where we tend to congregate, so let's say not a kitchen, not a bathroom, not a living room, right? Which is where we're typically going to be hanging out. If we dump it into a hallway space or somewhere close to where the return is for our space conditioning equipment, we do not see much of a comfort issue. It sounds like a lot of a comfort issue, but when we talk about 100 CFM, that's less than what is typically delivered by a bedroom register, right? And remember, we're still maintaining 70 degrees inside the space. So it does not become as big of an issue as it sounds in application. Now, if we dump that air directly into a living room or something like that, where we're not sensing and where we're all kind of hanging out and chilling and we're not moving around, we can start to feel uncomfortable, yes. So it's more about where are we placing the water heater. Now, in your market, typically you're going to dump it into a basement. You're going to keep the water heater in the basement, right? Basements are typically going to be larger than 700 cubic feet by quite a bit. We have not seen very many issues and very much comfort issue in those situations, especially if that basement is finished and being conditioned. I hope that answers the question, because like a typical building scientist, I'm going to give you the answer to every question of, well, that depends. And that's the proverbial wrench being thrown in a proverbial wheel. It always is going to depend. So, yeah, I hope that answered the question
I think
satisfactorily.
Anna?
Yeah, I guess my thought was that sadly, I have already purchased I've already been in a project where one of these hot water heat pumps has been installed, and it's not an LG because it's already been there for close to a year, and the LG was not available in Canada. So it's a completely electric residence. So they're already operating a heat pump for supply air. And then, with this heat pump water heater, it's dumping the cold air that they're trying to heat up. And because we're in Canada, we're usually in heating mode.
Yeah. No, absolutely. And your question really was more specific. Can it be mitigated through the use of an ERV?
Right.
Could it potentially? Maybe. Would it make sense? I don't know. Mainly just from an aspect of, I don't know how much I would feel comfortable with even myself making sure that my coil on my air to water or my heat pump water heater and the filter is so super squeaky clean that I'm now willing to pass my fresh air through yet another filter and yet another coil before I deliver it into my living space. Because again, if it's through an ERV, that is going to be my fresh air. Unless we're adding a secondary ERV just to temper that air. In which case, I would just simply say is, what's the cost trade-off? Because again, the trade-off to condition 100 to 200 CFM of 55 degree air, I would say is far less than reconditioning or tempering 200 CFM of negative 10 degree air coming into the space. Does that make sense?
Yeah, fair point.
So the next question comes from Michael Ingui. Oh, what? How did he cut the line? How did that happen? I mean, one of the nice things about being the person asking the questions is I cut the line. So I'll be super quick with mine because I really only want to cut the line for a second. Boy, you had mentioned that one of the things you'd love to do with teams that have technically difficult projects, and this hot water heater question reminded me of it. And I definitely have projects that fit that bill, where it's a 4-story house. I'm always trying to do things that it's supposed to do, and I want to do a passive house. They're all electric. how serious are you, and how do people interact with the team at LG to make that happen? You had mentioned it early, so I want to bring it up again. I think John put it really, really well. I actually took a picture of it. Thanks for the really great information. Wonderful to see this level of thinking from a supplier. I do think that the team that LG has is one of the strong suits here. So how do you recommend people handle that?
So I'm going to go back to, let's see. I'm going to go back to the very first slide, and I'm going to leave it there. So that's going to be my contact information. What I wish I did is I wish I would have convinced our marketing team to just go ahead and slap a contact web page that I could use a QR code to direct everybody to, to our ads team. So we have a team that we are affectionately calling the ads team, ADS, Application Design Service. Used to be the builder team, but they didn't like being called builders because they felt like it was pigeonholing them into something they don't want to do. And then sorry, I just got lost there. I saw somebody keeps their weed in a closet and a pantry there, so that's a good space. I mean, I would prefer something more hydronically balanced for that, but our ads team is nationwide, and they are more than happy to help out. Now, when it comes to our Canadian brothers and sisters, reach out to me, and if I don't have the bandwidth to help you out, I will happily put you in contact with one of our team that does have the bandwidth to help out. Whether you reach out to me on my email here on screen, my cell phone, or LinkedIn, either way, I am usually very, very good at responding within a day or two at most, because I do travel a whole lot and I do give a whole lot of trainings and presentations. So I may not be able to get back with you right away, but I will absolutely get back with you and either help or put you in touch with someone.
All right, next question. Peter. Sorry for jumping the line, Peter.
No problem whatsoever. So I think like Michael, I'm also looking for similar kind of typology building where and trying to electrify as much as possible, decarbonize as much as possible. We're talking 1 family to 4 family size buildings where ideally we could use as much of this as maybe even phased retrofits, because, passive house is great for gut renovations, but it's, phased retrofits. There's a lot of money on the table carbon wise to work with there. And what I'd love to be able to do is have a solution for homeowners and building owners where we could say, you've got a hydronic, heating system with cast iron radiators. I'd love to be able to use as much of your existing infrastructure as possible. You've got 3/4 inch copper pipe and you've got radiators. Can we get you, proper comfort by just replacing your boiler with some kind of, monobloc or heat pump solution? And if that can also be tied in where we have, a cooling solution as well, even better. Yet still, if in the summer we can harvest the waste heat from cooling and drive that into either domestic hot water, anytime we're just closing that loop and, not, the waste heat shouldn't be waste. Heat is energy. It's just not in the right place. We need a place, ideally it would be great if we could harvest heat from where we don't want it and put it somewhere where we do want it. And domestic hot water is a year-round load.
So that sounded to me like a 3-part question. So
probably
I'm going to do my best to answer it as a 3-part question. The last piece you brought up is the waste heat and redirecting that waste heat into somewhere usable. Love the concept. That's exactly what I was kind of talking about when I was talking about my teaser, the brain teaser, really. it becomes expensive and the cost outweighs the benefit until we get to density. So just like passive, right? Passive house is going to remain 20 to 25% more expensive in the very best case scenarios versus code in single family residence. But once we go to high density, we start seeing differences where passive actually can come out cheaper, or at least operationally comes in cheaper for sure. But even first cost, we are seeing differences of maybe like 1 to 3%, right? So density is key when it comes to maintaining that cost parity of taking excess or waste heat, so to say, and just shifting it into a place where we actually want it, from the wrong place to the right place. So that's the last piece, right, that I will touch on there. The other two parts really were more along the lines retrofit-wise. So I'm going to answer it from two different perspectives. One is, can it be done? Yes. Is it feasible from a cost perspective? Yes, it is. And you're right, there is so much money on the table for that. I left my former employer because it was all about IRA money, IRA money. We're going to have IRA money for the next 10 years, and we're going to get all these millions of dollars. And not a one of them, smart people with a C, with a C in front of the other two letters in their title, ever sat down to think about the fact that the same amount of money that IRA made available nationwide over 10 years was the amount of money that freaking, like, just the Northeast alone spends every single year through state and utility rebates for exactly what you're saying. So there is a ton of money out there. How do we do it? First, I want to go back to the one principle that we should absolutely hold highest above all, right below Jesus and wife, on the hierarchy of things when it comes to retrofits is AWE. A-W-E. Audit first, weatherize second, and then electrify. If we simply go in and we want to electrify that old boiler that provided 250-degree freaking water to a radiator, why did we do that? Well, so many people think it's because of Legionella. Bullcrap. Legionella needs oxygen to survive. So if it's a closed circuit, there's no Legionella. Secondary, if that system's running for 5 minutes at 125 degrees, Legionella's dead. So Legionella ain't the issue. The issue is that, you could fly a pigeon through the hole in your assembly, so you needed a radiator to overcome that cold air coming in. If we weatherize, then we no longer need that higher temperature of water, and now electrifying that water system, that hydronic system with those cast iron radiators, becomes much, much more feasible. Adding conditioning to like the cooling side, in that case, that's exactly what we want. Like, I convinced my best friend up in upstate New York to do it because he's got some solar panels on his roof, and it's a beautiful thing, and he's making his own electricity. I was like, bro, what are you doing with these window shakers? Like, it's a pain in the ass, and they're noisy, and you only cover one room at a time. So let's throw in a small little Unico system with small duct that we don't have to affect the aesthetics of an old building as much as we would with regular duct. And between them and RIA duct system, we now have options, right? But that's exactly what he did. He just simply added a couple of units to the areas where he really wanted conditioning for cooling, that he needed cooling, and then he just retrofitted a boiler system for everything else. And now a single system provides both cooling, heating, and the benefit that I see we get there is when it comes to radiators, when it comes to in-floor, we get a beautiful benefit of thermal storage, right? That thermal mass is amazing in the deep of winter. But it sucks at the end of September when it's 6 o'clock in the morning and you need just a little bit of heat to get you through the morning shower. But then by 1 o'clock, 2 o'clock in the afternoon, you want some cooling in the space instead. That's where we now have the ability with that DX, or not DX, I'm sorry, with the hydronic air side coil to provide heating in the morning and cooling in the afternoon, even in the Northeast, without having to worry about how long is it going to take for this heat to dissipate from this concrete floor.
So with the Hydrokit system, like how many BTUs can that thing throw out for conditioning space? How good do I need to get some of these old leaky buildings before I can tighten them up a lot, but there's a certain amount of destructiveness where I'm not going to get them to even interfit unless I'm.
Here's what I would say, and this is just me speaking out of my butt. Now, my butt is fairly well educated in this, so I'm going to say I'm going to get
This
the.
is why I'm consulting your butt. Exactly.
Thank you. This is very helpful.
Thank God this is not being recorded, right, Mike?
Of course, nobody will
I'm
ever
gonna
hear
edit
this.
this out.
And by the way, this is super important. And Peter, I'm happy to have you on. Great work, by the way. But I think Jordan jumped off. But a lot of us are doing these projects in our area. The first question we're asking ourselves is, how much do I have to do to some of these houses to get rid of my heat?
Yeah, absolutely. So I'm going to answer that again from two perspectives, because building scientist, it depends. I don't know that I would use Hydrokit on anything single family. I don't know that I would use Hydrokit on anything that is realistically below, let's say, maybe 10 tons.
Say that again? Sorry?
That is realistically below 10 tons.
Gotcha.
Hydrokit makes sense on a larger scale because cost versus density. Anything below that, I think we are better off with a monobloc type system. And unless you absolutely have no way of making it work, which in some of these older multifamilies, that may be the case, I would say decouple your space conditioning from your domestic hot water. And again, I go back to what I said earlier. I love redundancy, and I never like putting two life-saving systems into one component that when it fails, everything fails. And anything built by man will fail. It's not a matter of if, it's a matter of simply when. It will fail. And then the question becomes is how serviceable is it? I spent close to 10 years working with and for, and I'll go ahead and say it, Mitsubishi. Mitsubishi's failure rate is one of the lowest by far in the industry. LG has gotten there as well, to where our failure rates are freaking low. That comes with one really, really big problem. If contractors aren't replacing the same damn part at least once a week, the distributors aren't stocking that part because they figure, we don't need it. So now it becomes a game of your system has become so good that in a rare situation that it does fail, it takes you a week to get the freaking part because no one stocks it locally, because why would they? They haven't sold one in 3 years, right? And they need shelf space. So I don't like combining systems unless I'm doing it in a large enough scale where I have that redundancy already built in. So my thought when I was talking about this multi-family all-in-one system is I have a bank of multiple condensing units outside that are feeding multiple Hydrokits that are now delivering water for every use that I need to all the different spaces. And if one of those components fails, it's okay because I have enough to basically pick up the slack. Maybe I drop a little bit capacity and my runtime increases, but it's okay because I can still keep everybody comfortable and give them hot showers until the part comes in and we go ahead and replace it and we're back up to capacity. Does that make sense?
Yeah. I mean, but a lot of the places I'm looking at anyway have, if they're lucky, a mod con boiler with an indirect tank.
Mhm.
The boiler goes down, everything goes down.
Everything goes down. So
But
if we have the
if the power
opportunity to
goes down,
decouple,
everything goes down.
yeah, and if we have the opportunity to decouple, and not only that, but to take advantage of the money that's available, because remember, heat pump water heater money is separate from space conditioning money. I'm not quite sure yet, because I have not seen it applied, where we can take a system and get rid of a boiler, right? And then utilize one hydronic system to handle both domestic hot water and space conditioning, where we're able to take advantage of both of those credits at the same time on the same project.
When I was talking about money on the table, I was being figurative. Money on the table, I mean, as if you are looking at some of the most common systems across the United States in numbers of buildings, the US on average isn't super dense. Cities are dense,
Yes.
but vast tracts of suburban and rural lands and houses and buildings are heated terribly. And if we can find a way of decarbonizing as many of those as possible, lower the threshold for retrofit. So I can say, you've got a system, I want something to come up with a plug and play system that's very attractive, where I could say, replace your boiler, and for a small, hopefully small, increase, you can also get space cooling. And and again, if ideally you can use your waste heat to at least preheat maybe your
Yeah,
domestic
the
hot
whole
water.
combo, the whole combo.
The
Mhm.
whole
Yeah,
combo. If you can get that and get
Mhm.
that at at small scale, because there's so many of them.
Yeah.
It's
Yeah.
that is doable. Absolutely, it is doable from a perspective of our multi-V heat recovery. So the single phase heat recovery systems that we have that can be utilized with the Hydrokit, like you're saying, and then using the DX side to solely recover that rejected heat and dump it where we want it. Or again, is to your point of staging the retrofit, handle the hot water first, handle the space conditioning next, and you can kind of take it out in bite-sized pieces. So we do have the option to do it with two separate components, monobloc and heat pump water heater, or the option to handle it with a multi-V with a Hydrokit that now can do both the the domestic water and the space conditioning as well. So the solution is there. My answer to that question, and I guess was a roundabout answer of, it depends on what is the application, what is the budget, and what is it that we are trying to stage and how we're trying to stage it. Because I love stage retrofits, right? Not very many people can come in and say, oh, I want to electrify everything. Here's $50,000. Go ahead and do it. They're a lot more likely to do, okay, 3,000, 4,000 here, 5,000 here, 10,000 here.
Hey guys, I'm seeing the time. I want to make sure we rapid fire through some of the next. And by the way, that was great. That could have been like a whole little just presentation. That whole.
Oh, we can talk about that for like freaking 2
hours. Thank you.
Oh, forever.
Yeah. So Stephen, if you're still here, you're next. Maybe not. Jessica, if you're still here, you're next.
I was just wondering how long they're expected to last. I think you said there was a 10-year manufacturer's warranty.
So on the which components?
The domestic hot water tank
The water
and
heater?
air to source. Yeah.
So the domestic hot water heater has a 10-year compressor warranty. So because the compressor is warranted, we warranty the entire unit for 10 years. They are expected to last for far more than that. So we have them in Europe right now that have lasted for longer than 10 years. These units right now, the ones that are in the US are on there, I want to say third generation. The original generation is just now coming up on like 10, 11 years in Europe. So we're still seeing them functioning. We have not replaced very many. So more to come on that as we kind of age them and we really see real world what their lifespan truly does come out to be. On the air to water heat pump side, however, it's a little bit different because we are still working to get the ASHRAE ratings on the air to water heat pumps. We are working with a couple of other hi Ashley. We are working with a couple of other manufacturers in tandem to get those rating standards done so that we can then have the ability to offer an extended warranty. But the manufacturer's box warranty right now is 7 years compressor, 1 year parts.
And where is it manufactured?
I'm sorry?
Where is the manufacturing location?
These are made in South Korea. The air to water heat pumps are made in South Korea. Currently, the heat pump water heater is also manufactured in South Korea. Within, I want to say, the next 3 or 4 months, they are going to be manufactured in Alabama. So we have a facility in Alabama already that's already producing our air handlers, a few other components, and we are currently almost done with the heat pump water heater production line. So that production will switch entirely to Huntsville, Alabama.
Thank you.
Well, that's fun. Looking forward to that. So Ashley, you're next, and hi.
Hi guys. Good morning. Great to see you all.
Good to see you again, Ashley.
My God, thank you so much, boy. I somehow had no idea that you were meddling in all these wonderful hydronics. So I'm gonna get a hold of you. But so may have missed this, but are you selling the monoblocks now or distributing them in the US now?
Yeah, they've been available for about a year and change now.
Okay, amazing. Okay. And then for these kind of dual buffer tank, chilled water, heating hot water projects, do you have like a feel for how many gallons of storage is kind of like a sweet spot for, I don't know, just taking advantage of some of the thermal energy storage and also not having an entire garage full of tank? Like, where are you guys landing on that sort of design?
Yeah, so from our engineering published data standpoint, we call for a minimum of 15 gallons to prevent short cycle. What I did is at my house, I added a 50-gallon tank. So I have and it is a direct tank. And I will couch it and say this. I prefer direct over indirect. 100%. Like Nick said earlier, the efficiency penalty and capacity penalty paid for using glycol in the entirety of the system is so small compared to the penalty paid by going indirect. And I can tell you that in my home, going direct was a far better option. With my 55-gallon tank, or 55 gallons total capacity right now, I buy myself about a 20 to 25 degree temperature differential between no buffer and buffer when I'm shutting down my compressor and my outdoor unit. I reach that point and I shut it off, and the pump continues to move air through the system for another minute to, it's built-in safety. And then between the next time my cooling coil comes on, and that water has now increased in its temperature. So from an efficiency standpoint, obviously, the more the merrier, but there is no sweet spot per se outside of saying, let's figure out how many zones, what are the sizes of those zones, what's the operation going to look like, right? How are we using our control strategy? How are we controlling the system? And then that'll help us kind of figure out like what water temperatures am I going to see? And does it make sense to increase that capacity, right? From my perspective, I wanted to try to figure out, can I do this in a way that anyone can approach from a cost perspective.
100%.
So instead of paying $1,500 plus for a true buffer tank at 50 gallons, I went ahead and I called up a supplier and I said, hey, do you have any scratch and dent 50-gallon electric water heaters? And my buddies at Ferguson said, sure, here's one. Give me $100 for it. Perfect. And I put in that, and guess what? It is functioning beautifully. Now, I installed it not in the garage. I installed it outside. I installed it in luckily I have a little shed that had space that's right next to my air-to-water heat pump. So it was literally like a 5-foot run of 1-inch line into the shed, into the water heater. And then I double insulated the water heater. So I've got R26 on the water heater, and it's inside a shed, so it's shaded from direct sunlight, and it performs wonderfully. It really is just going to depend on the application, but I will say, if you can do 40 to 50 gallons, I like that sweet spot just because the calculations tell me that I need about 5 to 7 minutes worth of water pumping through the system at that cold temperature in order for my compressor and my outdoor unit to catch up to the supply. And 40 to 50 gallons buys me that 5 to 7 minutes. That's in my application.
Awesome. I have so many more questions about controls, but we'll talk offline. Thank you so much.
Come to the Heat Pump Summit. I know you were just in Boston. Come back out in November. There's not going to be any mosquitoes this time around.
Conversations are happening. Thank you for letting me know that's going on. A couple weeks. Appreciate you guys.
Have a good one. So next up is Gene. I might be missing Gene. Dean, are you next? Are you good? You're here?
Turning on here.
Yep, you're good.
All right, trying to bring the camera up. Yeah, I just had a quick question in regards to, I've worked off-grid for energy for 30 years and a lot with off-gridders, but I've seen the hot water tanks put into bathrooms on purpose so that, back to some of the points you've already made, that radiated losses are beneficial on a cold bathroom. So moving a hot water combined or a heat pump water heater into the bathroom, the moisture out of the room, free dehumidification, and it's already warm. But just curious on just ducting out. Is there any issue just running a single wall? No restrictions or no bigger restrictions, right?
Okay, repeat the last 30 seconds of your question because you broke up real bad.
Yeah, I have a bad internet connection. I was wondering in regards to just running an exhaust duct to take the cold air out to an adjacent room while you're using warm bathroom air for intake air.
Yeah, I love that idea. I love that idea.
Okay.
I love the idea, and I'm still working with a couple of really smart folks of building out a test situation where we potentially use that cold air discharge to dump it into a pantry. So let's call it a European style cold room that we create intentionally, knowing that it's going to be lower humidity and it's going to be a 10 to 15 degree lower temperature in there, which becomes very beneficial now with the perishables that can be stored in there without spoiling, without going bad. But, again, we got to think about, okay, how do we move air through those interstitial spaces to make sure that we don't condense and then have nowhere for that moisture to go. So again, we've talked about this until we're blue in the face, and Joe and Gary will both say, mold and mildew isn't an issue from a wet surface. It's from a wet surface that isn't able to dry. And how do we dry a surface? By air movement, right? So taking that hot, humid air from the bathroom to feed the water heater and then dump it into an adjacent space through the use of ductwork is a perfect application, a perfect idea. And as a matter of fact, that's what we predominantly do in Europe. So like if you look at LG's marketing material as it pertains to the heat pump water heaters, 99% of that material is going to show that water heater being installed somewhere in a bathroom. Because a bathroom or a kitchen is an ideal space. It's typically where we have excess heat and excess moisture that can help our heat pump water heater function more efficiently. And then we can take that dried, somewhat cooled air and dump it back into the space. So yeah,
Good.
I'm a fan of it.
Okay, that's what I thought. I've seen some pushback from code people saying you can't do things like that. So but when we see it work in the real world, I'm glad
the only people that hate change more than builders and contractors are code officials.
Agreed.
All right, we got our last question. Stephen, or Stefan, sorry, if you're here.
Hi, you mentioned that there were early issues with bringing this technology from Europe to the US. Could you go into more details to what those issues were and how they've improved?
Okay, I gotta try and think of where my brain was when I said that there were issues bringing it to the States. When it comes to the air to water heat pump, the main issues that we've seen is how we in the US view comfort versus how Europeans view comfort. Europeans are happy on a 90-degree day to have their set point inside being 80 degrees, which is 10 degrees below ambient, and they're comfortable. Good luck getting an American to say, oh yeah, on a 90-degree day, I love being in my 80-degree house. Hell no, we want it like 63 degrees inside. So some of the issues that we've seen is just the way that they design their hydronic systems in Europe with the water temperature, like the delivery water temperature, and then using mixing valves and things along those lines. The way they use the system and find it comfortable, they still reach a good COP, 3.5, 4, 5 COP. Whereas that same exact layout in an American home, the way we want to be comfortable, we're like barely at like a 1 COP, one and a little over 1 COP, right? So the issues that we've seen is simply from how easily we can over-engineer the crap out of a system to deliver comfort at the price of efficiency. So what we've done is we've actually gone in and kind of changed some of those piping diagrams to remove some of the options. And we do say verbally, these systems are so agnostic that you can pretty much design them any way you want. But we don't show you that pictorially because we don't want anyone coming and saying, well, LG told me to design it this way. No, we're telling you design it as freaking simple as you can. And then if you want to go any more complex, do it at your own merit. But we will tell you just try to go as simple as you can. That's why, like one of the reasons why Nick said, we prefer you use third-party controls for everything is because we don't want third-party controls for some things and then our controls for other things trying to argue who's got supremacy. Third-party control, if you're going to use it, let it control everything. Right? So those are just some of the issues that we saw with the systems coming in from overseas. The other is we've got to be considerate that these systems were built for the European market. They're not redesigned for the US market. Vast majority of manufacturers that are bringing in hydronics will happily redesign them for the US market once we have enough products selling in the market to actually justify that R&D cost. So what you will see inside an LG Monobloc, for example, is that it has thermostat inputs for a third-party thermostat on the board. I'm using an Ecobee to essentially switch the unit from cooling to heating into command, cooling call versus heating call. It's also doing that to command my dehumidification, because in my dehumidification mode, what happens is my thermostat calls for Y, so my outdoor unit goes on and it provides 40-degree water, but it also commands my air handler to go into the lowest possible speed for the fan, so I can actively dehumidify. I have those inputs on the board on the outdoor unit, but they're 230 volt. They're designed for the 230 volt thermostat, which is common in the European market and in the Asian market. So the issue that we see is like, okay, we have to change our approach and our application design documentation to say, throw in a couple of cheap relays and call on the thermostat through the relay just to make sure that you don't start burning stuff up because a contractor just thinks that, hey, you know what, it's fine. I can go ahead and just wire direct. And if I cross wire, nothing's going to happen. No, you're going to freaking backfeed 230 volts right to your thermostat through an 18 gauge wire. So those are some of the things that I kind of mentioned is, and I want to be completely upfront and transparent with these, because it's far better for us to say, do these things to make sure you are safe and your system functions the way you want it to, than to come out and say, oh, yeah, everything's perfect, everything's working great. No. It's not perfect yet because the technology is fairly new in the US and we still have to figure out how the heck we're going to use it. Because up until about 6 months ago, no one at LG ever talked about using a monobloc in a hot, humid climate for dehumidification purposes. The moment I said it, they were like, oh, no, we don't do that. No, we can't do that. And I'm like, why? Why not? Show me why we can't do it. And then when they sat down and I started being a stubborn ass and arguing with them, then they said, okay, fine, we're going to give you a unit for free, but you got to pay for everything else. And then we'll see how it works. And guess what? Right now, I am maintaining a comfortable 74 degrees in my house, which is my set point, and my humidity is at 53%. It's awesome. I haven't had that with my old DX system, my 16 or Linux. I never had that. So we can do some amazing things with this technology. We just have to be cognizant that we might have to try to figure out how to do it while we're installing. Well, any question?
Yeah, that all makes sense. Thank you so much.
And then, boy, I feel like, you know, that was the last question, but I wouldn't mind talking for a minute or so, and then we'll say goodbye to everybody. It's like 2 hours long. So first of all, thank you.
I do have a quickie.
Oh, there you go. Where I heard him.
Yeah, it's Mike. Yeah, first, a great presentation. I really enjoyed it. In comment to Ann's question about ERVs feeding the cold air into them, she needs to be aware, if she's watching, that if you try to feed directly into the duct of an ERV, one, you're going to restrict airflow from the heat pump unit, which could affect its efficiency, and that would be the main thing. So if you wanted to do that, you'd want to just feed the air discharge from the heat pump water heater into the vicinity, very close to the ERV's inlet, but don't put it straight into the pipe, because you would throw it, especially if it's a pressure balance system. You could run into issues there too.
Yeah, that's a very good point, and one of the reasons why I kind of mentioned, like, I don't know how much I like that approach, unless you are using a really, really good ERV. So a big shout out to our friends at Zender, because they can take care of it, they can accept it, but you would now have to use that ERV solely for the purpose of tempering the air for the heat pump water heater, and nothing else. And in which case, I don't think that financially that makes a lot of sense to me.
So, where I was going to go with this conversation is I feel like, one, that just coming back to my point, this is why it's exciting to see you guys over at LG. I mean, the team and the expertise, I think it was put very well earlier. It's just so nice to be able to have these open conversations. One, two, love it. You're forward thinking. We didn't spend this entire time just focusing on what you have now. We've talked about on things you want to have next, and that's where we're going. So this was really wonderful. I'm looking forward to that next conversation you mentioned, and we'll schedule it pretty soon. So thanks.
Absolutely.
It was very cool. Hey, by the way, I noticed you guys are on the card for FIAS. Are you going to be at FIAS?
Yes.
So will I.
Yeah. Myself and Dave will be there. I don't know that we'll be presenting because I did not have time to put anything together for presenting.
Yeah, but you'll be at the show. You'll be on the floor.
But we will be there. We will be at the show. We'll chat. We'll talk.
Great.
I'm looking forward to seeing everyone there. I'm going to be there. I think I'm going to bounce a little bit early. So I get there Monday morning.
Mm-hmm.
And I have to leave early Wednesday morning because I have to fly back to Houston, change my underwear because I get easily 2-3 days out of a pair, because inside out, backwards, forwards. But I still have to come back and change it before I fly to Orlando for 4 days for our dealer summit, which goes on from Thursday till Saturday night. So
good stuff. Well,
yeah, so I'm gonna have to bounce early, so I won't be able to see you guys at the big party on Wednesday.
Mm-hmm.
But Dave might actually stay there and hang out with y'all.
Sounds good. Well, I'm looking forward to seeing you there. I'm looking forward to seeing anybody else who's going to be there as well. It's going to be a lot of fun. And thank you all for joining today.